Welcome back. Today I'm going to be going over this SAT System of Equations question. And once again, thanks to Aniko.ai for providing this specific question in their free resources tab. But before I get started, please read this problem and give it a try yourself. Okay, so assuming you've read the problem already, right? Our end goal here is essentially to find after how many minutes when will the two plans have the same cost, right? Same total cost. Now, the tricky thing about this problem is that each cost has a different time interval attached to it, right? And that's actually, they're actually different time intervals for each of the plans, right? But I'll get later into how to diagnose that issue. But first of all, right, your goal for these word problems is to make sure, right, to unify, to make sure all the units are the same, right? And what I mean by that is, well, if you look at plane A, right, it gives us the cost of $15 per hour. But remember, right, the question is asking us the minutes, so we have to convert this into minutes, right? So $15 per hour, well, 1 hour is, right, 16 minutes or 60 minutes, and that gives us $0.25 every minute, right? 15 divided by 60 is 0.25. So that's the first thing, right? There's also $21 per hour, and I did say that we have to convert every unit into minutes, right? But I'll leave that for now, and I'll explain why later. Okay, so now that we have done that, right? I checked plan B. Plan B, there is no unit other than minutes, so we're good there. What's the next step? Well, this is where the unify everything comes, right? Just unify. You'll notice that there are different time intervals in this problem, right? There's for 60 minutes for plan A, there's 60, there's 60 minutes, there's 60 to 120, and then of course there's beyond 120, right? For plan B, there's first 80 minutes, right? And then there is minutes after 80, right? Or beyond 80 minutes. So how how do you write equations for each of these, right? Well, the first thing you have to do is establish a condition, right? Where where the number of minutes, right? The condition for the number of minutes has to be the same. What I mean by that is for plane A, right? If you notice, for the first 60 minutes, right, the flat fee stays at 50, right? It's 50. There's no rates there. So you do 50, right? You do 50 for the first 60 minutes. And this is for plane A. Then from 60 to 120 minutes, the cost increases at a rate of $21 per hour. Well, 60 minutes is 1 hour. 120 minutes is 2 hours, right? So from 60 to 120, there is a gap of 1 hour. But it tells you that the cost increases at a rate of $21 per hour, right? $21 per hour. Well, in this time interval, there's only an hour being passed. So you just use this rate, right? In that 1 hour, you have $21 that are gained. So from 60 to 120 minutes, right? You gain an additional $21, right? Okay, now what about beyond 120? Right, let's write that beyond 120. This is where you have to establish a condition. Let's say that x was the number of minutes, right? So what would inequality represent, right? If I did x is greater than or equal to 120, that would represent the number of minutes starting at 120 and beyond, right? because the minimum that x can be here is 120, right? So here you're starting at 120, right? Think of this as a timeline, and you're going beyond, right? Like in the future. So if we use that condition here, right, that x is greater than 120, then what do we do though, right? Well, look at plane A. It says for any time beyond 120, right? So in the future, right, after 120 minutes, the additional time cost $0.25 per 1 minute, right? We converted that unit. So if it costs a quarter every minute, right? And this is beyond 120, well that means for any additional minute, right? After 120 minutes passes, after 120, right? The cost increases at 0.25 per minute, right? So if x was our number of minutes, well then x minus 120, right, would give us the number of minutes that have passed after 120, right? If you think about it, right, if x was 120, right, well, this would just be zero, right? There would be nothing going past 120. If this was 121, well, then that would be 1 minute past 120. If this was 122, then this would be 2 minutes past 120, right? And likewise. And then we know that for every minute after 120, that you make $0.25. So you multiply this by 0.25. So now we have the total costs for each interval. So you have to add them up now, right? So you do this plus this, right? This gives us 71 plus 0.25 times x minus 120, right? And that gives us the total for plane A. And once again, this is assuming that the number of minutes is greater than 120. Before I move on to plan B, right, with this condition here, because we're assuming that the number of minutes is greater than 120, that means we have to account for minutes 0 to 120, right? But we already did, right? We accounted for the first 60 minutes and then from 60 minutes to 120 minutes. So once again, that's really important to notice. So we have our total cost equation for plane A. Now for plan B, right? For the first 80 minutes, there is a rate of 0.65, and then for each additional minute after 80 minutes, you add 0.30 per minute. So the key thing, and this is where a lot of people mess up, right? This is actually really important for this question, right? Once again, you have to unify everything. In this case, when I say unify, I mean that the condition that you establish in the previous equation for plane A has to be the same condition that you're establishing for plane B, right? So x still has to be greater than 120, right? And the reason is because you don't want the equations to represent different times, right? You want time to be constant, right? If you think about it this way, plan A and plan B are coexisting together in the same time, right? So, well, how do you find that? How do you find the total cost with this condition? Well, for the first 80 minutes, right, it says it's a rate of 0.65 per minute. Well, that's going to be 0.65, well, per minute, well, in the first 80 minutes, that's 0.65 times 8, right? And I'm going to put that here. This is going to give us 52, right? So for the first 80 minutes, our cost is 52. Then we have to actually make another interval, which is from 80 minutes to 120, right? So from 80 to 120, well, we know that for each additional minute after 80, you make $0.3 per minute. Well, how many minutes are after 80 here? 40, right? Because the gap between these two is 40. So you do 40 minutes times, well, 0.3, right? Because you make that much each minute. So you do 40 times 0.3, you get $12, right? So that's our second interval. And now, what about the minutes after 120? Well, I'm going to call this beyond 120 again, right? So for the minutes beyond 120, well, what you're going to do is the same exact thing, right? Here we said x minus 120 times the unit cost, right? This is the same exact thing, right? This is x minus 120 times the unit cost. Well, how much does each minute contribute to the cost? Well, that's still 0.30, right? Because you're still adding $0.30 after every minute after 80 minutes, right? So once again, right, if x was 121, that means it would be 1 minute after 120, right? If x was 122, that would be 2 minutes after 120, right? And likewise and so forth. But now we have our total cost equation for this, right? For plan B here, which is 52 plus 12, so 64, plus 0.30 x minus 120, right? And that's the total for plan B. So now, oh yeah, once again, right? This is not really necessary, but write it, right? Again, same conditions, right? Make sure this is actually a good place to check before you move on, is make sure they're the same conditions. Well, now you have the same equations, right? And they have the same time condition applied. So what you can do is go to Desmos, type them in. So you have 71 plus 0.25 x minus 120, right? That's plan A. And then for plan B, you have 64 plus 0.3 times x minus 120, right? And then you get these two lines. And if you look at the intersection point, right, it's at 260, comma 106, right? So these equations here, they intersect with each other, right? They have a solution. The system has a solution at x equals 260, right? And that's going to be minutes, right? So after how many minutes? Well, 260, right? Which is answer choice B. So just to recap, the first step for this problem is to unify the units. So what I mean by that is to make sure all the units are the same. And to figure out what unit that should be, look at the answer, right? Look at the answer, look at the question. It's asking us to find the minutes, so we have to convert everything in terms of minutes. After that, your second step is to make an equation for both of these, right? Plan A and plan B. But you have to make sure that they both have the same time condition, right? Which in this case is for minutes after 120. So this is x greater than or equal to 120. But before I end this video, you might actually be wondering, well, why did I choose 120 and not 80 minutes, right? And my shortest answer to you is always choose the bigger amount, right? It's easier to deal with. It's way easier to deal with if you choose the bigger amount, right? And once again, right, because you're trying to keep the same time conditions for each plan, right? So we're keeping x beyond 120 here, and we also have to do beyond 120 here. Make sure that you don't miss any intervals, right? So here I calculated 80 to 120, right? Because we still have to represent the total cost, right? And x beyond 120, well, you still need to include the intervals before 120 minutes, right? So you have to include all the missing intervals, right? So yeah, use this unify approach, right? And just to sum it up, you have to unify the units and you have to unify the time conditions, right? And then of course from there you can just plug into Desmos once you have the equations and get your answer. So hopefully that made sense. If it didn't, I know this was more of a wordy-ish problem. Um, Please leave any questions you have down in the comments. But again, thanks for watching, and I'll see you next time.